Hey everybody, here we go with Breakout 16. This is the last of the Breakout videos that I'm going to be doing. It's been a long journey to get to here, and I think you're going to like this one. Okay, so this particular episode, if you hit a particular brick, it will fall all the way down. And then if you hit it with your paddle will get bigger for, I don't know, maybe 5 seconds and then go back to the normal size. So there's a fair amount of stuff going on there, but I think we can do this, and I think you'll start to see the power of objects and being able to change the different kind of object and then figure out how you're going to have it interact with the world. And that's what's really fun about these games, is you can just like use your imagination. You come up with all kinds of things. You could have a falling brick that if you hit it, then suddenly your paddle will catch it, and then you can move it around, or maybe it'll become another ball, or maybe you hit a brick and it becomes like 3 or 4 balls. There's a lot of different things that can happen here. But anyway, hopefully I've sparked your interest enough and shown you enough things in Breakout so you can really have some fun with this. All right, so let's go ahead and get going. Again, what we're going to do today is we are going to work on the falling brick. So falling brick. And to begin with, let's go ahead and make some bricks that are going to be of the kind falling. So we'll scroll down to make bricks. And here's make bricks. Again, like line 80, 82, this is where if-then statement is. Okay, so we've created a random number. If it's greater than 95, it makes an invisible brick. If it's greater than 90, it makes a countdown brick. And let's make one to say if it is greater than 85, then we will make a falling brick. Okay, so new brick equals brick. We need our brick rectangle. And let's make these ones pink. Not only pink, but hot pink. Let's see, what comes after that? The number of points. So a falling brick, I don't know, let's make it 100 points. And the kind is falling. Okay. So that should create a hot pink brick. Let's go ahead and run that. Let's see if we get some hot pink bricks. Yeah, okay, so it picked up 2 here. Okay, so let's go into our constructor of our bricks and start make some falling bricks. Okay, we're going to scroll up. Here's our constructor. Okay, so we have if self-kind is a countdown brick, we're going to show the text and we're going to make it a countdown brick. Okay, so we need to have probably something like this. If self.kind equals falling, self.king, self-falling. So what kind of things do we need to do when we have a falling brick? Well, we need to show the text. And when we draw the falling brick, let's look down here. When we draw the falling brick, we don't want it to draw the countdown. We want it to draw the number of points. The number of points will be falling. So let's do another if statement here. If self.kind, I don't know why I keep typing king, equals falling, self.brick text.draw, and we need F quote, and then we're going to do the curly brackets, and we're going to do self dot points. So when we run that, that should draw the points up on the thing. So let's see what we get. Something. Okay, it says Breakout. Did you mean self.kind? Line 41. Self.kind equals 41. Okay, run. Okay, so now look, notice how our 100 is kind of scooched over. So we really need to create a different text box such that our 100 is more nicely formed in here. Okay, so let's look back at our constructor and see if we can do that. Now, let's self.bricktest. This is where we're actually creating our text box. So let's do this. We're going to do a command X, and I want to have our countdown text box and our falling text box to be slightly different. Okay, so our brick text for the countdown one, we know that that one's right, but this falling one, instead of 12, let's make it maybe 4. Let's see what I got. Yeah, let's run that. Okay. So now we have 100 points, and when we hit those, what we want, like if I hit N to start this game, when we hit those 100s, we want those 100s to start falling, okay? And they're not falling yet. Okay, so what we're going to have to do is change the Y value on that brick inside the loop, and it'll fall, okay? So let's see what we can do there, okay? We are going to have to, we got to do a couple things. One is, I think we're going to have a variable inside our brick to say whether the brick is falling or not. And then if that brick is falling, then we're going to move it. Does that sound good? Okay, so let's see what we can do here. So that can be just like self.falling here. We'll drop it here. Self.falling equals false. Okay, because it's not falling yet. Okay, so let's go down now and look at where we are, where our ball and brick hit. Okay, so that's inside of our game loop. Okay, so here is our ball brick interaction. Okay, so elif ball.kind is countdown, blah, blah, blah. So this is the countdown one. So we need to do something elif b.kind equals falling. You know what? I didn't use the double equals. Okay, so if it's falling, all we really need to do is say b.falling equals true. You know, we have ball brick interaction, and then we have ball paddle interaction, but now we need brick paddle interaction in order to check to see if the falling brick has now hit the paddle, okay? Because if the falling brick hits the paddle, then we want the paddle to get bigger and do all kinds of stuff. So let's see what we can do about creating that. Here to maybe ball paddle interaction, maybe right after ball paddle interaction. Okay, so we're going to go here, and we are going to say brick paddle interaction. So we're going to need to do a for B in bricks, okay, because we're going to go through all the bricks. And then we're going to say if b.kind is equal to a falling brick, okay, because we need to know if it's a falling brick, because if it's not a falling brick, we don't really care, because if it's not a falling brick, it's not going to interact with the paddle, okay? So we need to see if b.kind is falling and b.falling is true, okay? Remember, I could do equals true, but I don't have to do the equals true. I can just say it's falling, okay? So if it's falling, if the kind is falling and it is falling, then we need to see whether or not the brick hit the paddle. Okay, so we could say this: if pygame dot rect, remember, dot collide rect, and we need to check the paddle rect and b.rect, okay, which is the rectangle of the brick that's falling. Okay, so say they hit each other, then we need to do a couple things. We need to bump up the score, b.points, right? NTS, okay, so there's our points, right? We need to say paddle W, okay, wonder why that's underlined. Paddle W times equals 2. So we're just going to multiply it so our paddle gets twice as big. Sound good? And let's see here. And then we're going to remove the brick. So we're going to say brick dot remove B, okay, because we can get rid of the brick, right? And that's if it hit. Now it's bricks dot remove B. Okay. Now otherwise we just need to keep that brick falling, right? So what we need to do is we need to set our rectangle for the brick. We want to set the Y part of the rectangle for the brick a little bit more every time so it keeps falling, okay? And the way you do that, and this is kind of tricky, is you type in b.rect, okay, that's our rectangle, that's part of our brick, and then we're going to say equals, and then we have to reform the entire tuple for the rectangle, okay? And the reason you have to reform the entire rectangle tuple is because tuples are what's known as immutable, which means once you've created them, you cannot change a little part of it. You have to like recreate the whole entire thing, okay? So again, tuples are immutable, and strings are also immutable. You can't just change part of a string. You have to like redefine the string. Okay, so not terribly hard. Just one of those things you got to sort of keep in mind. If you do some Java work, Java is very similar. Okay, so we're going to say b.rect sub 0. Okay, sub 0, b.rect sub 0 is the x-coordinate of that rectangle tuple. And then we're going to say b.rect sub 1 is the y-coordinate of that tuple. And we're going to go ahead and add 5 to it because we want to increase that y so that it falls. Now, if you want it to fall faster, you'd make that plus 10. If you want to make it slower, you'd make it plus, I don't know, 2 or something. What did I do? I think I bumped it. Okay. And then we need b.rect sub 2, and then b dot rect sub 3. Okay, so our rectangle has now been redefined with just the y value being increased by 5. Okay, so let's run. Okay, so I'm going to hit N. Let's see, when I hit one of those, that should start falling, and it does. And notice how my paddle got bigger. See that? So now I hit spacebar. Oh, my paddle's still big, so we may have to fix that. Let's see if I catch that 100. It's kind of fun. Whee! Oh, now my paddle's even bigger. So I noticed a couple things. Well, one, the paddle doesn't reset itself back to small. And two, when the brick is falling, the 100 doesn't fall with it. Okay, so we got a few things that we got to figure out. The other thing that I wonder is that brick fell, but did it ever get erased? Did it ever get removed from the, from the list of bricks? And if it didn't, then, I think our code would never allow us to start a new level. Okay, so we got a number of things that we got to sort of do. Now, typically what I would do is I'd write those down as a programmer, but I kind of got them up in my brain because I've written this code a couple times getting ready for this lesson. So let's go ahead and close, and we're going to check to see if the brick goes off the screen, and if it does, then we can remove the brick. Okay, so that's pretty straightforward. We can say if b.rect, and we want the y value of the rect, the y value is 1. We can say if that is greater than the screen height, then we can get rid of, we can say bricks dot remove b, right? Get rid of the brick. Okay, so that takes care of that. Now, let's see what we can do about making the text fall with the brick. Let's go up and take a look at our draw routine, because in order to draw our bricks, we just go through the list of bricks and we draw them at whatever x, y. Line 51, here's where we're drawing our rectangle, right? And line 55, here's where we're drawing our text. But our text, we need to actually change the y value of where that brick text is in order to have it fall with the rectangle. Okay, so that should be pretty straightforward. That would be self dot brick text dot y. Okay, so that's our y value of the brick text, and then we're going to say equals self dot rect, which is the rectangle that we're already dealing with. Now that rectangle has changed, right? That rectangle has changed because we changed that as it was falling. So, and we want the y value of that, so that's the 1. And then we want also the +3, because we had a +3 shift when we're actually creating our brick text. So let's see if that works. All right, run. Okay, so there's the 100, and notice that when it was falling, that 100 was falling with it, and then it stopped. Now, I want you to notice that now our paddle is twice the size, right? So we want a couple things to happen. When we go to a new ball or a new game, so to speak, we want that paddle size to be reset to where it's supposed to be. And I think that paddle width was 80. So let's go ahead and see if we can reset that paddle width to 80 when we get a new ball or a new game. That should be pretty straightforward. That's right here inside of our game loop where we hit the N key or the space key. We can basically, right here, we can say paddle W equals 80. And right here, paddle W equals 80. Okay. So when we run that, if we fall and we hit it, okay, we got a big paddle, and then when I hit space, it should go back to its normal space, right? Okay. Now that's great, but during the gameplay, what we want to happen is we want the paddle to be big for a while, and then we want it to drop down to 80 after a certain amount of time. Okay, so let's talk about time for a little bit. Remember how at the very beginning of our game loop, we know that our game loop happens 60 times every second, right? Okay. So if we put a little counter in there, say 300, we can just say, some counter equals 300. And then every time we go through the game loop, we subtract 1 from it. So it becomes, 299, 298, 297. Then eventually it'll get to 0. Okay, it'll get back to 0. And once it gets to 0, we can check for that. And we can reset our paddle size. Okay. So let's see what we can do there, because I think that's pretty straightforward. Now what we're going to need is we're going to need some sort of a counter, and I think the counter is kind of like the paddle counter. Like, in other words, the paddle will grow big for a while and then it'll shrink. So let's create a paddle counter, and I think we ought to put that with the rest of the paddle stuff that we designed. So we're going to just type in here, like 125, paddle counter equals 0. So we need to do two things. One is when we catch the ball, or when the paddle and the brick interact, we need to bump that paddle counter up, and then we need to count down the counter until it gets to 0, in which case then we can make our paddle smaller again. So let's go look at our paddle brick interaction. Remember that little routine? So paddle brick interaction, I think it was down a little bit. Okay, so paddle brick. Okay, so here we go. So here we've doubled the size of the paddle width, right? And we can say paddle counter equals 300. Okay, you can make that whatever. You can make it 500. I mean, it really doesn't matter. But you want to make it something. And then let's scroll down. Actually, here's where we redo the. Let's put our paddle counter thing here instead. Paddle counter minus equals 1. Okay, and then what we can do is we can say right here, if paddle counter is less than 0, if it's less than 0, then we need to do a couple things. We need to set the paddle width back to 80. Yeah, that'll do it. That'll do it. It doesn't matter if the paddle counter keeps going negative and negative and negative. I mean, these computers, they run so darn fast. So let's play. Okay, so we're going to hit N. Oh, I'm not very good at this. Come on, here we go. Okay, so we caught it, and then it got big. Now, the moment I hit space, it's going to go back to the regular size. Okay. Oh, that would have been nice had I had that extra little bit. Okay. Oh boy, just barely caught that. Okay, so the game is significantly easier up, and now did you notice how it, after about 4 or 5 seconds, it went down? Oh, look at that. I still got a little bug where it catches the ball. That's kind of fun, though. So that's it for Breakout 16. There's a lot going on there. There's a lot of logic. There's a lot to play with, and I found that quite interesting. There's so many different things that I would like to do to this game, and I may go back and revisit it. Probably the biggest thing that I would do is I would make the ball and the paddle objects themselves, because then I can have an object interact with another object, and I think it makes the code a lot cleaner. But as you grow as a coder, you will get better at making your code clean and easy to read and easy to understand and maintain. So, but anyway, that's it for Breakout and Breakout 16. Next, we are going to be going into Flappy Birds and getting into some graphics and sound, and that's going to be so much fun. All right, I enjoy the journey with you. Take care.